So we can solve again some practice questions here. Produce a truth table for the gate combination below and then show that it behaves like a NAND gate. You can just provide the truth table here. You know that we have two inputs, so in our column of inputs we'll have A, B, we have 4 rows. Okay, 0 0 1 1 0 1 0 1. Okay, then we have C and we have D. You better label immediately after each gate ikusaidia kwenye table include output na input zote. Okay, so we know C is the inverse of A, so ni 1 1 0 0, and D is the inverse of B because of this NOT gate, so you invert 1 0 1 0. So finally, to get our Q, it's an OR gate which combines C and D by OR gate is addition. So just simply add 1 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 ni 1, 0 plus 0 ni 0, and you get your answer like that. Show that it behaves like a NAND gate. Okay, so there are two ways. Later tutasoma kitu tunaita Boolean algebra. Okay, tutasoma Boolean algebra. Kuna njia mbili, unaweza ukaprove kwa Boolean algebra au unaweza ukaprove kwa kuchora truth table ya NAND gate. As you can see, truth table ya NAND gate mwisho wa siku lazima iwe na 1 1 1 0. So we can see from our NAND gate here it is 1 1 1 0. So hence you have shown that NAND gate can also be presented by this gate here, negated OR gates. As you can see, they look alike. Okay, 1 1 0 1 1 0. Okay, yes. So we have another question there. You can solve here. You can try for yourself to provide the truth table of this, then you can just text me. Okay, you can provide the truth table here. You can solve this one here, and you can solve this one here for your practice. Again, we have a question here. Maybe I should just give you a hint here. There are only two inputs here. Okay, there are only two inputs there, so the number of rows should be 2. So you can label here P and you can label here Q. You know that this, you trace this, it comes from A, so this is A, and you trace this, it comes from B. Again, you have E and F, and then you can easily find for Q. Remember, these are NAND gates, these are NOT gates. For this one, again we have two inputs, so the number of rows will be 4 to power 2. Amesha kulebia hapa C, amesha kupa hapa D, so you know that what enters in this gate is A and D, and what enters in this gate is B and C. Okay, C and B. So their outputs are E and F respectively, in which they enter the NOR gate, the OR gate, NOT gate, to give the output of G. Then you can try that on your own. A conceptual questions, if you are really understanding what I've been speaking, you can try this one here. Just a conceptual question, that a vending machine is to be controlled by the logic arrangement shown below. A vending machine is to be controlled by the logic arrangement shown below. Kwenye vending machine ambapo kuna button na delivery, so depending na unataka upate nini na nini ndio utabonyeza. Kwa mfano, kama unataka upate kahawa uchanganye na maziwa, uweke na sukari au uweke na chai, it depends na utabonyeza nini. So the switch can either be switched 1 or 0. So explain what happens when the button is pressed. Do this for at least 2 selections. Kwa mfano, nataka black coffee, nita switch 1. It means hizi zote zitakuwa kwenye 0 kwa sababu sijazi switch on. Therefore, since it is an OR gate, when you add them itakutoka 1. It means coffee itakuwa switched on, utapata coffee. Kama ni kikombe working up. However, kwa mfano nikiwa nataka nika press labda white coffee, automatically this switch will be 0 kwa sababu sijai switch on. This will be 1. Okay, again since nime press, this will also be 1. Okay, this will be 0, this will be 0 because I haven't pressed them. This will be 0, all others will be 0, so we don't have to worry of the other gates. So it means for white coffee it will switch on for milk because OR gate, when you sum them up here, it's 1, so milk will come out and again coffee will come out. So when you mix, you find that you get white coffee because milk is white and coffee is black, so automatically your coffee will be white due to the milk. Explain what will happen if two buttons are pressed at the same time. For instance, I decide to press black coffee and white coffee, so you follow the path. Or this time I might change that you press black coffee maybe and tea. If I press tea and black coffee, automatically this will be on, so this switch will be on 1, and tea goes to this gate here, so this will be 1, and again this will be 1. But all these others, there will be zeros because they are not switched on. The only gates that will be affected by tea is this gate here and this gate here. Okay, so since black coffee was also switched on, for this gate here it will be 100 because the others are unaffected because tea does not affect this gate. So automatically the output here will be 1 plus 0 plus 0, so it will be 1. Coffee will come out. Again, since I pressed tea will affect this gate here, that it will switch on 1 and the others will be 0. So since it's an OR gate, it will sum up and give output as 1, so milk will also be released. Lakini pia hii tea itakuwa imeaffect hii gate, umeona, kwa itakuwa switch 1 while this is 0, so again ukiadd inakuwa ni 1, so na tea utapata. So ukiplace black coffee na tea kwenye kombe chako, utajaza coffee, utajaza milk na utajaza tea. So this is how a simple application of this logic gate can be illustrated.